Hello, my name is Solomon Lubwama, and I'm going to share with you the hardware and software used in creating multimedia. It has been said that computers defy description. At one time, the computer was considered the ultimate solution for which there was no problem. But that's not quite correct. The computer is a simple beast and it does basically one thing. It takes input and then modifies that input to create some form of output. The enormous potential of that simple activity, however, is what makes the computer seem like such a complex device. Computers are now making it possible to combine sound, images, and motion together. In this presentation, we introduce you to the inside story of multimedia, that is, about the hardware and the software which enable you to get the end product called multimedia. Understanding these concepts is very important, as it is only the hardware, the software, plus your conceptual understanding and skills which will be crucial for multimedia development. At the end of the presentation, you'll be able to outline the hardware requirements for multimedia development, list various software for developing multimedia, and choose suitable software for developing multimedia. I/O, commonly written as I/O, stands for input and output, which are the two things a computer does best. In fact, input-output is pretty much the only thing a computer does. You get this whole input-output concept down and you've tackled the essence of what a computer is and what it can do. The devices connected to your computer are divided into two camps. There are input devices and output devices. Input devices are things used to send information to the computer. The keyboard and mouse are two examples of input devices, as are a scanner and a digital camera. Output devices are things the computer uses to show its output, such as the screen and printer. The central part of a computer system is processing. If a computer did no processing, it would essentially be like plumbing. Water would come into the system, churn around in a few pipes, and then go out of the system. The water would be the same before, during, and after the journey. But with a computer, you have the added element of processing, which means doing something to the input so that you get something else as output. Processing is the stage where the input data is manipulated in order to produce meaningful information. Processing is handled by a device inside the computer called a processor. The processor doesn't really know what to do with all that input. Telling the computer what to do is the job of software. It's amazing when you think of it. Computer input is all digital, yet with the proper processing, the output can be anything from a poem to a graphical image to a symphony. That's all thanks to the power of processing. A byte is a collection of 8 bits. A bit is a unit of information expressed as either a 0 or a 1 in binary notation. The final part of the computer equation is storage, which in a computer is referred to as memory. The storage is necessary on the most basic level because the processor needs a place to perform its magic. On a modern computer, storage comes in two forms, temporary and long-term. RAM is the temporary storage where the processor does its work, where programs run, and where information is stored while it's being worked on. RAM is the microprocessor's playground. Disk drives provide long-term storage. The disks also allow information to be saved and recalled for later use, like a closet or storage unit. Disk storage is the place where things go when the microprocessor isn't directly working on them, but from where stuff can be retrieved later if need be. A computer system is a blend of two things, hardware and software. Hardware is the physical part of a computer, anything you can touch and anything you can see. The computer console, the monitor, the keyboard, the mouse, that physical stuff is hardware. Software is the brains of the computer. It tells the hardware what to do. Without software, hardware just sits around and looks pretty. It can't do anything because it has no instructions and nothing telling it what to do next. The most important piece of software inside a computer is the operating system. It has several duties. 1. Control the computer's hardware. 2. Manage all the computer software. Organize the files and stuff you create on the computer. Interface with you, the human. Computer software is known by several different names. In addition to software, you find 1. Applications. This category of software is used for productivity or to create things. Applications are the software that does the work. Programs. Anything that is a computer program is also software, but this category includes software that may or may not be used for productivity or to produce output, such as a computer game or CD playing program. Utilities or tools. These programs are designed to help you run the computer or work with the hardware. For example, you may use a tool to optimize the performance of your computer's disk drives. You use software to control your computer hardware, and the result is that you produce something. That something, whether it's a document, a piece of music, a video, graphic art, whatever, is stored on the computer in a unit called a file. The operating system is what tells the various applications and programs how and where to save the stuff you create, that is, your files. The operating system helps keep things organized and offers rules for naming and help for finding all those files. Hardware required for multimedia. To begin your quest with a multimedia project, you must have a decent computer. A decent computer means you should have adequate hardware. Hardware interprets your commands into computer activity. As of now, if you are asked to develop a multimedia project, you would ask for a fast computer with lots of speed and storage. There are many more things that you need to know, like which component makes a computer fast, what is the device for storage, etc. The components are thus divided into 5 categories. 1. System devices. 2. Memory and storage devices. 3. Input devices. 4. Output devices. And 5. Communication devices. We shall start with system devices. System devices are the essential components for a computer. These include the microprocessor, motherboard, and memory. Microprocessor is basically the heart of the computer. A microprocessor is an integrated circuit that contains all the functions of a central processing unit of the computer. When you turn your computer on, it is the microprocessor which performs some operations. The microprocessor gets the first instruction from the basic input-output system, or BIOS, which is a part of its memory. BIOS actually loads the operating system into random access memory, or RAM. A motherboard is a device in the computer that contains the computer's basic circuitry and other components. The motherboard contains computer components like microprocessor, memory, basic input-output system, expansion slots, and interconnecting circuitry. You can add additional components to a motherboard through its expansion slot. Memory and storage devices. Computer memory consists of a collection of consecutively numbered registers, each one of which normally holds 1 byte. A byte is a collection of 8 bits, sometimes referred to by those in the computer communications community as an octet. RAM, random access memory, also called primary memory, locates the operating system, application programs, and data in current use so that the computer's processor reaches them quickly. RAM is called random access because any storage location can be accessed randomly or directly. RAM is much faster than the hard disk, the floppy disk, and the CD-ROM. RAM can be taken as short-term memory and the hard disk as the long-term memory of the computer. However, RAM might get slow when used to its limit. That is why you need memory to work on multimedia. Today's personal computers come with 128 or more megabytes of RAM. Users of graphic applications usually need 128 megabytes or more of memory. A hard disk stores and provides access to large amounts of data on an electromagnetically charged surface. Today's computers typically come with a hard disk that contains several billion bytes of storage. The popular ones currently are 40 GB and above. Hard disk contains a part called a disk cache, which is responsible for improving the time it takes to read from or write to a hard disk. The disk cache holds data that has recently been read. The other type of hardware cache inside your computer is cache memory. Cache stores something temporarily, e.g., temporary internet files are saved in cache. A compact disc, commonly referred to as a CD, is a small medium that can store data pertaining to audio, video, text, and other information in digital form. The CD was introduced in 1983 as a medium for playback of music. CDs have the capacity to store 74 minutes of audio in digital stereo format. Initially, CDs were read-only, but newer technology allows users to record as well. The CD-ROM, CD read-only memory, can store computer data in the form of text, graphics, and sounds. CD-ROMs are read-only because they are stamped from a master disk, similar to the way that audio CDs are created. Normally, this type of CD is either CD recordable or CD rewritable. In the CD rewritable, you can use the CD as a floppy disk, that is, write, erase, and again write data into the same disk. In the CD recordable, once the data recording is completed, it becomes a CD-ROM and nothing can be deleted. To record data into a CD, you need a CD recorder. DVD, which is short for digital versatile disc or digital video disc, is a disc capable of storing large amounts of data on one disc, the size of a standard CD. DVDs are widely used for storing and viewing movies and other data. To play DVDs on a computer, you must have a DVD drive and software DVD player. Physically, a DVD and CD look the same. Both discs are the same size and typically have one side with a label and the other side that the laser reads, unless it is a double-sided DVD. However, the technology that makes up a DVD allows for the same size disc to hold a lot more data than a CD. CD-ROM and DVD technology is appropriate for distributing large amounts of data inexpensively, especially when there are many copies to be made, because the cost of creating a master and pressing the copies is distributed over the cost of each copy.